So I'll just tell the story about how I met Xiaowei Liu. It'll be probably a good background. I was reading a book called The Satoshi Affairs. It's just an old history book on Bitcoin a long time ago. And in that book, there was an attorney called Jimmy Nguyen that was mentioned in the book. And so I was just Googling names. And this guy ended up being an influencer on Twitter. And all of a sudden, I'm like, oh my gosh, Jimmy Nguyen. I started following him on Twitter. He was going to be in Silicon Valley, and he was from like Tokyo or some other place. He was originally from California, but he was going to be out here. He's like, I got to find this guy, Jimmy Nguyen. I want to go meet him. He was going to do a meetup like this. It was in Mountain View. This is 3 years ago. I show up, and it's a big thing like this. Actually, pretty much bigger than this. We have a dinner afterwards, and I sit down right next to him, and we're hitting it off. And he's like, we're talking like, he's like, I want you to meet someone. I'm like, yeah, who? He's like, I want you to meet. This is how he described it. He's like, I want you to meet the most important man in Bitcoin. And I'm like, I was kind of taken back because he wasn't joking. And he says, this guy right here, Xiaowei Liu. And I'm like, oh, I got to meet this guy. I'm like, what's the deal? So, that's a little preview. That is from a very credible person that said that, patent attorney, influencer in the space for many, many years, who I really respected for a long time and followed that. And that's how I met this guy. And, the technological inventions that he created so far thus are basically revolutionary, that will basically, bridge the entire Web 2 world to Web 3 with the development tools. So I'll save that for him. My name's Gavin. Nice to meet everybody, and thanks for having me.
Thank you. Hey, thanks for the intro,
Yeah.
Gavin. Okay. Hi guys. So my name is Xiaowei, as Gavin and just mentioned. I created this company called sCrypt. So for me, a little bit of background. Before I get into this Web3 crypto, I was working at Facebook with my, one of my colleagues is here, former colleague, sorry, in 2017. I think I left because I just feel this technology, I think is the future. I don't know what exactly to do, but I feel there's some opportunity there. So I just create, and then since actually, funny story, when I first created, I actually ran an office at One Piece, in Mountain View. Okay, so glad to see you here. Some old faces here. So for sCrypt, what we do, we already, a little bit more background about me. I'm like a developer, researcher at Facebook as a research scientist. So I was always coding, and I'm just interested in this technology. So when I first get into the Web3, I'm like everybody else. I jump into Ethereum, and later on I was on. Anybody here heard about it? Still remember EOS? EOS? Okay.
Yes, yeah.
Yeah, sure. Yeah. I got into ICO, So, I thought that was Bitcoin's blockchain 1.0, Ethereum 2.0, EOS is like 3.0. Of course, I jumped into the latest, right? But later on, long story short, when the launch, I tried to build some ads, but it didn't work out much because the chain itself has a lot of issues. That's they claim a lot of good things in the white paper, but we all know it's not always the mainnet launch is not always as good as the the white paper claims. So at that time it was 2018. So there was a big thing going on in the Bitcoin land called scaling debate, right? And then I kind of I was always curious because when I first got into crypto, I never actually paid any attention to Bitcoin because that to me, the idea is, you just buy Bitcoin, you hodl, the numbers go up, you profit, right? That's not much you can build upon it. So I'm a builder, so I just dive into other blockchains, so-called smart contract platform. And then later on, after I dive into, because I want to understand the Bitcoin technology. So after that, I spent almost like a full time, 2 months. I did nothing else, but I sleep, I eat, and then I research Bitcoin. After that, I just dropped everything. I just went all in Bitcoin since then. So at first, I was into Bitcoin Cash. For people who not know the scaling debate, that's a fork. And then later on, I was also in the Bitcoin S3. But since last year, because the audio stuff is kind of like blowing up, finally some activity that can happen. You can actually build stuff on Bitcoin. So that's why I also, let's say, expanded our support also on the Bitcoin, or the UTXO blockchain. So that's what we offer. I think it's a very unique approach because most people who build, even for people come here, They are built on like EVM blockchain or Solana, right, or Su or Aptos, whatever. Just very few people understand. Hey, Bitcoin not only you can is an asset, a digital gold, but also you can issue tokens. But also today I'm going to tell you also you can build smart contract. So that begs the question, right? If Bitcoin can do everything, and is most the biggest market cap and the most decentralized and most secure, why do you choose to build on any other blockchain, right? So that's a question worth debating. So, so for sCrypt, we are pretty much for people. How many have developed on Ethereum? Okay, quite a lot. How many heard about Infura?
Infura.
Okay, Infura or Alchemy. Okay, so we are pretty much like the Alchemy or Infura, but for Bitcoin. Okay, so that's if there's only one message takeaway, so that's good. Is Infura for Bitcoin. Okay, so we offer developer toolings, including the APIs. For example, you don't have to run your own node. You don't have to run all the token indexes. There may be like 10 indexes today you have to run. You don't have to maintain them. We all offer SDKs and also APIs. You don't have to run anything. You just it's like an Infura. You go there, you create an account, you get an API key, and then you use our SDK to build anything. Pretty much, if you just some simple app, you can pretty much build it in like a couple of days. You can. So you don't have to know anything very specific about the underlying technology. So how do I switch this? Okay. So it all comes back. Why we have sCrypt. We found it about end of 2019. So we jump on different Bitcoin UTXO blockchains. But why do we even exist? Okay, it's all coming back. As I said, I spent a lot of time doing very in-depth research into the history. Where does the industry come from? It's all starting from this guy called Satoshi Nakamoto. Right? He had this quote, okay, on Bitcoin forum in 2009. Okay, so basically what he said in today's world, so I built Bitcoin not only just to be electronic cash. I also want it to be a platform that you can build applications on. I mean, in today's world, right, you got Web3 or smart contract platform. In his own word, he said, I built this thing, you can transfer value, but that's like the only one, the first application, right? It's like, Bitcoin is like iPhone, okay? It's a phone, you can call your buddy, but that's probably not the primary use case. He said, I built this thing, it can be electronic cash, you can send around across the globe, but I also want to support a lot of other applications, for example, escrow, or multi-party arbitration, or let's say, let's say auction, right? Or insurance. He called them different transaction types, right? Because the most common one used today is a simple transfer from Alice to Bob. But if Bitcoin is only for digital gold, right, he wouldn't build this complex system. So that's why when he designed not only for cash but also in today's terminology, he also want this to be a smart contract and token platform. You can do everything you can. Right? That's the quote back then. So how does Bitcoin can achieve the use cases other than the simple case of money transfer? It all boils down to this word, and then so it's using this so-called underlying model, so-called UTXO model. Anybody? How many people heard about this term? UTXO. Okay. What does it stand for?
I don't know what it stands for, to be honest. What? I've heard of it.
Anyone?
Just
transactional.
Great. I think. Let me get you some sticker later. I'll give you some tokens. So as he correctly points out, it stands for unspent transaction output. So for Bitcoin, right, it's a little bit different. It's so-called even in the white paper it says it's cash, right? So cash means it's like cash in my wallet. You have dollars. You have different denominations, 1, 2, 5. Right? You may have 4 $5 bills, right? It's cash. So that means I don't actually I have a balance, the balance is the sum, the total sum. It's not like a Ethereum or like, let's say the banking model, right? You have an account, it's a gigantic spreadsheet, so everybody has an account. And then when you transfer, one is credit, the other one is debit, right? The sender from the sender to the receiver. So that's a so-called account model, which is popularized by Ethereum or EVM or Solana, which is using the banking model, the account model. Versus in Bitcoin, when you pull up a Bitcoin wallet, if it says you have, let's say, 100 Bitcoins, you don't actually has a account entry in the ledger says, hey, this Alice has 100. Actually, it's all split up in across. It's like a change money, your cash. So all the Bitcoins you have, they are stored in separate, most likely multiple transactions. And in Bitcoin transactions, simply put, you have input, you have output. Okay, you always have inputs, outputs. And if the output, if somebody wants to spend some output, it has to like a reference. The input has to have a pointer, almost like a reference. You have to say, hey, which output you are spending. So by the name, right? If it's unspent, that means the money is still there. You cannot spend it. And one of the most important problem the Bitcoin solve is double spend prevention, right? Because if I have only one $5 bill, you don't want me to go to buy a burger and then spend the whole same money to buy some gas. Right? You cannot spend one UTXO, one output more than once, right? So that's a guarantee it has. So the model is again used for, in Bitcoin it's called UTXO model. This is in smart contract with the account model. So it's all the money, all the Bitcoins you have, they are stored in separate UTXOs. And then that begs a very natural question, right? What if you have my Bitcoin in my UTXO, you have your Bitcoin in your UTXO? What if I can spend your UTXO? Does the system work?
Will not.
Right? No.
No.
You need some way to control the access, right?
Yeah.
So think about output is almost like a lockbox, right? Or even your mailbox, right? You have address, and somebody if they want to mail a letter, so instead of letters, they put if they want to send you some Bitcoin, they put in a slot into your mailbox, and only whoever has a key, he can unlock it, right? So that's the model, the Bitcoin programming model. You have your Bitcoins, it's locked up in the UTXO output, and it's a lock, and the lock has a corresponding key. Only whoever possesses the right key, he can open the lock and take the Bitcoins out, right? Simple enough. By the way, I want to make this interactive, so any questions, just interrupt. That's okay. Okay.
So for output, we also call it pre-image, right? Pre-image.
Pre-image? What do you mean?
Okay.
No, it's a separate,
Yeah.
probably a separate concept.
Okay.
So it's just output. Every output has a lock. So the most popular lock is, you can only access it, you can only open it with a so-called digital signature, right? When you send, your Bitcoin from Alice to Bob, that's usually what happens. It's locked up. The lock says, I need to check you have the right signature from this, address. Address is almost like a public key.
Mm-hmm.
So for people who know like a Bitcoin or any kind of cryptography, using so-called asymmetric key system, right? You have a private key, only you know, and it has a public key, anybody can know. Okay, so this pretty much says, hey, only one who can access this is the one whoever holds the private key, so he can produce the right signature. Right? So here's a key. Here's a highlight. That's only one type of lock. You can have many other type of lock. So all these locks, they are what essentially so-called Bitcoin smart contract. So when you send to somebody's address, that's like just one type, one simple type. It's like a hello world of Bitcoin smart contract, which check the signature. But you can have arbitrary. There's some limitation, but under these practical limitations, you can do all kinds of locks. For example, you can say, hey, I don't want some key. I want to have some passcode. You know, in the Bitcoin land, it's called a hash lock. Right?
Hash lock, yeah.
You know, you need some right preimage and hash the right, you know, hash value. Or you can have even more advanced, a time lock, right? Basically, it's almost like a check. I'm probably too old here, but for people who's younger here will not heard about checks. On check, you can also write like a time, date. Hey, before this date, this check is not bad. Yes. The same here. You can say, hey, even you have right key, if let's say before 2030, you cannot move this coin. You can say that. You know, you can even do more advanced. You know, you can combine all these different. You can say, hey, you can even have multi-sig, right? Oh, if we have, let's say 20 people here, if only more than 10 people we sign, then this coin can move. Otherwise, it cannot move, right? You know, usually this is in some kind of bridge, right? You can have multi-sig. But all I'm saying is, you can think about Bitcoin contracts as like a function, and then the key is argument. So if what the Bitcoin the miners do or all the full nodes do is to, hey, if I evaluate this function, if it returns true, that means, hey, you are authorized to spend the coin. Otherwise, you are not. Okay. So far, so good. Or so good. Yeah. All good. Good. Okay.
So a locking protocol, that's what you're talking about.
Yeah, you lock, you unlock. That's it. That's the primitive. Okay. Everything else can be built using this primitive.
Like
looks very similar. Looks very simple, but actually I'm going to show you later.
A time lock, though, is what you're saying.
It's just one type of contract. You can do all kinds of contracts. You can even combine them, right? You can say, hey, to lock you need 3 out of 5, but also after this time. Or you can say, hey, and you need this hash per image plus 4 out of 10. You know, you can even
so
arrange all of them.
How far away is all this capability together compared to Turing complete?
So in the big BTC land, we call it the Turing incomplete because, for example, here you cannot do. Let's say you cannot easily maintain state because in account system, right, it's very easy to have some kind of state. For example, you can have ERC20.
What is state?
State is almost like in the current, you know, the snapshot of the system. You can think about it. It's almost like a memory. The computer system is almost like a memory. The current snapshot of the reality for each program. Okay. So basically, I'm going to talk about later why it's not that complete. Plus some caveat. If you have add something back, actually you can make it Turing complete. I mean, under the constraint of the block size. But for today, on the mainnet, it's very restricted, so it's not Turing complete. Okay. But if you add something back, as I talked about opcode, then you can become Turing complete.
So you can easily become Turing complete on Bitcoin Cash, right? Because they have a much bigger block.
Yeah, Bitcoin Cash and Bitcoin SV and some other UTXO blockchain because they have more opcodes, so they are actually Turing complete. But BTC today, without opcode, it's not. Okay. Because you cannot, let's say, maintain state, and also you cannot do, for example, let's say, unbounded computation. Okay.
Well, I think Lightning Network already, like I mentioned about Lightning Network, they already form a statement channel for the micro payment. Not that much, but
yeah,
still
it is. There's some capability, but not much, as you said. Yeah.
Do you have any like timeline for the EIP for the cat or cat?
I wish I know that. No, and you're right. You should probably ask Trump in Nashville. He said we have great miners. You know, we have the best miners. You should activate it tomorrow. You know, you should ask him. Basically, I think a lot in the final part of my talk, I'm going to cover this so-called opcode. So before I even jump into that part, I want to even give you an idea. hey, what is this like an opcode everybody's talking about, especially this specific one, called opcode, because Bitcoin, you know, it is so-called decentralized, right? It's not running by a single company or a single entity. It can be run by anybody who wants to download the client and just run it, right? And then because you cannot require, hey, anybody who download Bitcoin must run Windows or x86 or ARM. You cannot dictate the physical machine, right? So the way, how do you make it portable, right? Anybody can run it, of course. As like everybody here already know, right? You use virtualization, right? You build a so-called virtual machine. So which I call it, I think I may have invented this word, but you guys can check. I think I wrote an article about 4 years ago. I called it Bitcoin virtual machine. So basically, idea is you have a virtual machine, and each machine has a so-called instruction sets, right? You can add things, you can multiply things, you can talk things, you can push things, right? So these are the instruction sets for the virtual machine, which is so-called opcode. And usually it's because it's 1 byte long, so people also call it bytecode. Okay, so that's the word. When you hear opcode, that's the instruction set for the Bitcoin virtual machine. So when the miners or anybody who have the client runs, the previous one, evaluate the function, what it does is, in simple terms, simplified terms, you have the lock, usually called a script public key, because it's mostly like is a public key, and the key part is usually called the script sig, because mostly it's a signature, but I prefer to call it locking script and unlocking script. So what the miners do, or any client does is concatenate these two, put them together, and run the whole instructions set from beginning to end, linear. So that's what I say. It's not that Turing complete, because there's no, you don't go back. You cannot do recursion, or you cannot do unbounded loops. Does it make sense? Because it always runs from the left to the right. It's just one by one.
There's no go to.
There's no go to. Okay. Because then, what's the problem if there's a go to?
It's not peer to peer.
Not really.
If you're going,
yeah. Then
infinite?
you have the DOS attack service, right? Because if I can send a transaction to miners, which can cause an infinite loop, and the whole blockchain is stuck, right? People don't want to do that. So that's why have the Bitcoin virtual machine is always linear run executes from the left to the right. So if all this runs,
the way Ethereum doesn't run into this problem.
Yeah, Ethereum, because you pretty much has go to.
Yeah.
So you need to invent something called gas. You need to know, hey, how much I pre-fill some gas, a tank of gas. If the gas runs out, and then even the program is not finished, I have to stop, because otherwise anybody can DOS attack it, right? Okay, so it's just virtual machine is a stack based. Basically, all this code just manipulate the data on the stack. So if it is finished, the top of stack is true. That means this checks out, right? Mean returns true, and then the unlocking succeed. Okay. Otherwise it fails. So it's a very simple model. It's like a math function. This is check. Oh yeah, is this a solution for some kind of equation? You plug in the solution. If it checks out, you're good. You're authorized. You can spend the coin, move the coins. Otherwise, you cannot. Okay. And the function is programmed. Is represented in so-called opcodes. Opcodes is just. Can you go to the next? So this is a little bit history about the big so-called this kind of opcode. The stat is called Bitcoin script. Okay. So it's actually very similar to if you're coming from the Ethereum world. You have the Ethereum virtual machine. The Ethereum virtual machine also have a set of opcodes. It has some similarities, but there are also some opcodes that's not here. For example, I think you can do jump, and also you can do call some routines. You can do function calls. But here you don't have such. It's about 80 when it's first released. In 2009. So here's the surprising part. This is not something that's added to Bitcoin later. When first version came out, 0.1 in 2009, I think January 3rd, this opcode is already in the code. You don't have to trust me, you can go to SourceForge. That's a regional repo, it's not GitHub. You can go there and check the code yourself. That's what is committed there and people run. All this opcode is already there in 2009. Okay, so that also, reflects, leads us back to the first code, right? So when he first designed, Satoshi designed Bitcoin system, it's not only for cash, electronic cash people can send around. He can also build different, all kinds of, so he called it transaction types, but today we call it smart contracts. So you can represent any arbitrary function you want to code, all the spending conditions you can use it, combine all this opcode. Okay, can go next. So then, at the beginning it has almost 80 opcodes, but then there's some history, here, and that's something somebody changed the opcode. Okay, so that leads back to why we have the so-called Turing incomplete or opcode issue, because in 2009 he disabled a lot of them. So originally let's say 80, and then later on, for various reasons, he disabled. He pretty much removed, let's say 10 or 12. Opcodes.
Satoshi?
Yeah. Okay, it's not core developer. It's not somebody came up later. For some reasons, for security reasons, because he doesn't want to have there's somebody that can attack, this version, if all this code are enabled. Because back then, there's no cap. For example, there's no 1 megabyte block size cap. There's no, let's say, how big the stack element can be. Today it's 520, right? A lot of people know. But back then, there's no limit. So if you put a lot of things on, I think that's his concern. He said, hey, maybe somebody can attack this. Let me temporarily disable this. I think that's what he meant. But later on, people never enable it, okay? Even up to today. And then some developers later on add some new opcodes, and also add some new opcodes. For example, have the check log time, and also check sequence time. Basically, the time log I mentioned earlier. That's added up later on. And then you have segue to fix so-called mutability issue in 2017. And then later you have 2021 you have the Taproot, which introduced sCrypt. So basically, it's you can write longer script, pretty much. That's what it.
What is SegWit?
Like a segregated waitlist. So, long story short, basically, when you heard about the transaction ID. So every time you send somebody around, if you go to some block explorer, you can check the transaction ID, right? Some long random hash value, right? So segregated basically means the waitlist pretty much is the key. So originally when Satoshi first designed, released Bitcoin, when you calculate the transaction ID, you hash, the key as well. But the segregated means, hey, when you hash it, don't put the key out, don't, because there's some potential attack. So you just remove out. When you calculate the ID, it doesn't include the key anymore. So it's got segregated waitlist. Pretty much
separates the signature?
Yeah, remove the signature from the transaction ID. Okay.
Separates the digital signature.
Yeah, so the word is weird. Separate. Anyway, so that's a little bit of history. So basically, at the beginning, it has many opcodes. Later on, it's disabled, and then a couple of them were added back later. New opcodes were introduced, and now we are talking about, whether to re-enable some old opcode like opcat. Okay. Okay, go.
And that requires some sort of consensus with the Bitcoin core developers.
Yeah, you need some kind of so-called fork. It's not like,
So why ask Trump? Trump is not part of the approval committee.
No, I'm just joking. I think here's the thing, nobody knows how or when this thing can be activated, right? It's like, if somebody says he knows, it's probably, I wouldn't believe him, because this thing is like almost like, it's not like technically it's very easy. It's just 10 lines of code. I can go to GitHub, Bitcoin GitHub, I put up PR, it's only 10 lines of code, opcode. But then, how do you make sure other people in the ecosystem run it? Miners, exchanges, apps, or even, let's say, users. I think that's like it's not a technical thing. It's like a lot of times it's social or even economic. So if you guys around, about previous forks, it always takes, years, and then it's very political. A lot of times people have to fight, okay? And that's why you have forks, hard forks, like Bitcoin Cash, or Bitcoin SV, or eCash, all these, forks, because it's almost like a species. You are splitting different species, or it's like a religion. You are splitting into different, tribes. Same here. You have to be very careful because most people don't want to cause a hard fork. Basically means then you have two blockchains going forward.
Is opcode a hard fork?
It's a sort of soft fork. So basically means if you don't want it, you don't have to upgrade. You can still follow the chain. So hard fork means you have to upload to the latest. Otherwise, you are kicked out of the blockchain. So it's almost like forward compatible. So that's a soft fork. Hard fork means if you don't upgrade, you are kicked out of the network. Okay. So for opcode, this specific upgrade proposal is in form of soft fork. Soft fork usually considered as not that contentious as a hard fork. Hard fork is very, very contentious. That's like, almost like a nuclear option. Most people, they are thinking about soft forks. Okay. All right. So we talk about Bitcoin history, script, and what the Bitcoin system does, and then finally coming back a little bit into specific what sCrypt does. Okay. So sCrypt is a company that is a development platform that aims to make developing on building apps on Bitcoin or UTXO blockchains as easy as possible. Because just how many here have developed anything or any apps, anything on top of Bitcoin so far? Okay.
One.
Okay. Okay. How is it easy, difficult from level to 1 to 10? Compared to, let's say, Solidity, or let's say even build a website in Web 2.
Actually, I think the logic is a little bit different from the EVM. So that's the most difficult part to code. But actually the UTXO, the logic inside is very clearly and it's simple.
Okay.
So
the short summary is it's not that easy. Okay. For example, you want to build a website today, you have many open source frameworks like React, Svelte, anything you want. You can pretty much go use some open source code or even watch some tutorials on YouTube. You're ready to go. You can build a site. Okay, one day or two. But if I ask you, hey, can you build me like a NFT marketplace on Bitcoin? Or can you build me like launchpad for rooms or Minter, which is like one of the easiest app on Bitcoin, but I mean, you guys are very top coders here, but if I want to ask you to do this, my guess is probably not going to be like a weekend's job. Okay, it will take a long time for you, from scratch. You have to run your own node, you have to configure it, you have to connect it, to sync up to the latest tip, and then you have to know the different token systems, ordinals, Ruin, BRC20, SRC20, programming runes, bitmaps, atomicals. It take you weeks, if not months, okay, to be honest, okay? So we are solving the problem. Hey, guys, you don't have to develop from scratch. It's almost an analogy here is you want to build some, let's say, web app. You go to buy a server, you run it, you configure the ID, you buy the domain, you set up the wire, and then you build an operating system, you build an SDK. No, that's pretty much like on developing on Bitcoin today. We are solving this problem because for Bitcoin to take over, you have to make sure building on top of it is as easy as possible, as easy as building on Solidity, Ethereum, Solana, or Web2. You want to, hey, you're just Web2 developer, you don't have to any Bitcoin experience. You come here, you go to our site, you register, you get an API key, and then you can use our APIs. I think we have 3 tiers of APIs. We run all the infrastructure already. Bitcoin node, the indexes, all the tokens, your favorite tokens you can think of. So you can just then follow our tutorials, install our TypeScript, JavaScript, SDK, Go, Python. Then you are ready to go. You can build some, simple game maybe in 1 day instead of one month, or even sometimes take you one. Even sync up the Bitcoin node probably take you 1 week, and then you sync up the index will take you another week, and then you may crash. You don't want, that's too complicated. For that, it's never going to take over. Okay, it's never going to be adopted by the mainstream. We want to make it as easy as building just on Web2. Okay, so we offer SDKs, APIs, so you can go there and in 5 minutes you are ready to go. Okay, you guys can try after this talk. Okay, so one of our inventions, this is also why the name comes from, the sCrypt. So how many here know Solidity? Okay. Pretty much everybody. So what it is, for people who have not heard about it? Anyone? You get another sticker. Okay. A token. Airdrop.
Yeah.
What it is?
It's the coding language for smart contracts on Ethereum.
Yes, exactly.
Coding language for smart contracts on Ethereum.
So you can think of sCrypt is just Solidity, but for Bitcoin. As I talked about earlier, Bitcoin is programmable, but that's the issue. It only has the Bitcoin script. Right? Script is like an assembly language. Nobody codes in there. The equivalent is Ethereum virtual machine. It also has opcodes, as like a script-like opcodes. It has a stack, but most people, I've never met anybody who program Ethereum dApps using opcodes, because it's technically possible, but it's just too complicated. It's like assembly, right? You don't want to write anything, especially the big apps, right? DeFi, lending, whatever. It's just too complicated. So we are providing the solution here is, hey, you don't have to know anything about Bitcoin script, which is we handle all the things under the hood. So, and it's not only Solidity. I think it's much better than Solidity, because Solidity, we think it's popular within the Web3 community, because I think we had the survey is about globally that's like 30,000 active developers. So guess how much that's the Web2 developers out there? Have a guess.
On Solidity?
No, Web2 developers.
Oh, in the world?
In the world.
800,000?
Say it again?
800,000. Last time I checked 2 years ago.
Okay. You got to check the latest, but it's about 1,000 times bigger. So it's about 30 million people. Okay.
30 million?
Globally, yes. Okay. So that's the story. So the idea is to, hey, we want to onboard all these developers. We don't want them to learn something like Solidity, Move, Rust, Cairo. There's good languages, I'm sure, but not many people know about it, right?
Yes.
We probably know about it, but most people outside this movement may never even heard about it. So it's causing a lot of issues. So for our case, we decided, hey, we don't want to create some new language. We want to build upon existing language. We call it TypeScript. So basically, sCrypt is just a subset. It's so-called terminology called DSL, domain specific language. Basically, it's a subset of TypeScript. TypeScript, for people who have not heard about TypeScript, you probably heard about JavaScript. So it's pretty much like JavaScript, but with optional types, right? So basically, it's a subset. It's a TypeScript. It's almost like a JavaScript library. You can npm install, and then you are ready to go. You don't have to learn anything new language. It's just another library to you. for you to develop a smart contract. I think this is the coolest feature in this whole Web3 space. Okay, you don't have to learn about anything Solidity, Move, Cairo, or whatnot. You know, I mean, I'm pretty sure there's a good languages, but it's just not many people know about it. Okay, that's just a reality. Okay.
So I have another question again, as another of Web3, right? Can you think of a comparable Web2 framework that this sCrypt is
Like
playing in a Web3 world? For example, Django in a Web2 world?
Yeah, it's like React, Django, or
Node.js.
Node.js.
So
yes.
the question was, can she think of a Web 2 app that's similar to this Web 3 sCrypt? Is that what she said?
No, basically it's a TypeScript framework that enable you to develop Web3 apps almost as easy as Web2. So basically, I mean, we have a tutorial walk you through the typical, the very famous tic-tac-toe. You go to React, the tutorial, it walk you through step by step how to build, tic-tac-toe web-based game using React. We also have a similar thing. You can go there, check out a tutorial step by step, tell you how to build a tic-tac-toe, but runs on Bitcoin. Okay, so that's the difference.
I wonder, like, go ahead.
Can I ask Ken to just address his speech because he just calling
Okay.
interesting.
Yeah, sure.
So just 1 minute. Can you hear us? Kent? Yeah, could you unmute yourself and say hello
Yeah.
to everyone? So well, I'm so happy to get your support from Harvard Blockchain and get your calling to say hello to everyone. And for this event and the next regular event, we already approached a lot of BTC Core to join us, as well as a key author and researcher, not only from Babylon, but also from a lot of other layer 2. And for this event, we got the co-host from the Bitcoin Startup Labs and One Piece and SNA. They all showing their face. So would you like to make some address to say hello to everyone? And also, Kun also come in person. The blockchain, the Stanford
nice.
blockchain. Yeah.
Yeah,
So
it's
hello to everyone.
all good friends and old friends. I was in the Bay Area 3 weeks ago, so it's sad that I missed the event. Thank you, Nova, for the invitation. I represent Harvard Blockchain. Last year, I relocated to Boston for Harvard MBA, and I run Harvard Blockchain Club as the president. It's been an honor and extreme pleasure to interact with a lot of my old friends, from One Piece, from SNZ, from Stanford Blockchain, and so on, in my new capacity, as well as meeting a ton of new friends, from the industry. We run Harvard Blockchain Research, Harvard Blockchain Accelerator, and also organize our annual flagship Harvard Blockchain Conference. We like to support, builders, investors, community members to come together and really, pursue towards our dream. And we believe it's necessary to bring everyone's power together to achieve these. So thanks Vishwa and Hamster to putting this together. I think Bitcoin is one of the most exciting sector that we're focusing on as a club. So for the conference that we recently completed, we focus a lot on programmable Bitcoin, as well as new infrastructure, AI and DeepIn, and as one of the three most highly prioritized sector. This is something that we have a lot of interest in, and we'd love to support Hamster and going forward. Thanks again for your time.
Thanks a lot, Kent, and hopefully we could help this regular Bitcoin technology evangelist co-working or co-researching, or not only in Bay Area but also in Boston, to your place. Thanks a lot.
Yeah, absolutely.
Yeah,
Thank you.
Sure. Thanks a lot. So yeah. Thanks a lot for.
Yeah, thanks, Ken. Alan, you have a question? I think.
Oh yeah. like is sCrypt the only TypeScript kind of solution on Bitcoin, or do you have a lot of competing products?
So that's the only one currently.
For now.
So, you know,
Uh-huh.
I have never heard about
Cook.
another. Yeah, I think everybody else is doing programmable Bitcoin in script. If you are talking about building native layer 1 contracts, I think this is this is the only game in town for now. There are some other stuff like mini script or simplicity or Cypel is that called, but it's its own thing, and it's been probably longer than that, but it's not. Yeah, for various reasons, not popular. I think also we are not only high-level language, but also we have the whole framework. You can not only use us to program it, you can also deploy it, you can also call it, you can also integrate with different wallets and also different front end. We are like a full suite for people who are coming from the Solidity background. So we are like Solidity plus Ganache plus MetaMask. We built the whole vertical system, almost like a parallel tech stack versus the EVM. So in short, basically this is if you don't want to program Bitcoin contracts in script, this is the only option right now. Yeah. Another question, comments?
Why wouldn't you want to use script to program the contracts?
I'm not smart, so because it's just like maybe for small thing, very small thing, maybe you can want to compare two hashes, or if it's trivial, maybe you can do it. But anything non-trivial, you will want to build some kind of lending or DeFi or AMM or layer 1 token. I mean, in theory, it's doable. It's like, hey, you can, compute, let's say, trajectory of the. Maybe you can forecast some weather 7 days from now using your hand calculator. I mean, it's theoretically possible, but it's just too inefficient to be actually practical. Does it make sense?
Yeah.
In theory, you can do, but anything non-trivial, you probably don't want to. It's like a program JavaScript. You don't use JavaScript, but you use like V8 opcodes, or you don't use Java. You use Java.
So it has
Java
more
version.
functions, basically. Is that
It's
what it is?
much easier. It's like many orders of magnitude easier, simpler to program with. Okay.
I didn't fully grasp the significance of the opcode. Can you?
Awesome. Okay.
The
That's
significance,
the next slide.
the significance of the opcat.
Can you go to the